Welcome. Carrying on from our statistics conversations, we're going to be dealing with stem and leaf plots, which is basically a nice way of putting data in some kind of order so we can understand, get meaning from that data. So here I've drawn a leaf. Here we've got our stem coming down the middle, and off the side is all of our leaves. And that's basically what our information is going to look like. So let's get started. Our learning intent today will be that you will understand these leaf plots. We're going to understand that the information is about keys. When you look at it and you draw a leaf plot, it's basically a key. Stem leaf plots are very similar to histograms. We're going to deal with histograms in our next lesson, but for now we're just going to look at our stem plot. So let's get started. So let's say we have a whole lot of information. Okay, so here's the beginning of our stem plot key. On this side we have our stem, which is our main part of our leaf, or our tree, and then we have our leaf. Now let's say, for example, we added some data into here. Okay, so now what we're going to be doing, I've got our stem information here and we've got our late leaf information. And basically this represents numbers. For example, let's say this was scores on a test. So stem 1 is saying all the people that started their score with a number 1, so 1 and 2 is 12, and 1 and 6 is 16. So rather than writing all those individual numbers out, a stem and leaf plot allows us to put all that information together and make it more concise and easier to read. So for example, people that scored 20 and above, or in between 20 and 30, there was 22, 23, 24 and 27. Okay? If we were to count all of these numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, that equals 24 people, or participants, or whoever it is that you're doing your investigation, your statistics on. When we're talking about data, particularly in this case in stem and leaf plots, we talk about data as it being symmetrical or skewed. So symmetrical here basically means, is it more or less, so more or less centered in the middle? Okay. Okay, so if we were looking at our stem, okay, and we had some numbers here, we had 2, 3, you can see that this number here, or this stem here, stem and our leaf here, it's more or less in the middle. So we would say that was symmetrical. With skewed data though, talking about skewed data, we basically mean that it sort of is to one side or another. To one side or another. Okay, it doesn't matter which side. So if I said it was skewed to the left or the right, okay. So for example, let's say we know that this is our skewed data, but let's say we added a lot more figures here, then we could say that all this data is skewed this way. So if this was actually on a histogram that looks like this, it would actually be skewed to the left, which is this way here. Okay? Okay, so now we're going to do some practice. Okay. So this is our stem and leaf, which we're going to practice on. All of these numbers represent minutes. Minutes on a phone call that you made, many phone calls you made. So here, so for example, would be 8 minutes, 15 minutes, 19 minutes, 21, 34, and so on. So I would like you to establish how many calls took place. How many calls or phone calls to produce that data? What was the shortest phone call? The shortest call? Okay. What was the longest one? You should be able to see it from there. What was the mode? Remember what mode is? Remember our mode is the most common call length. Okay? So what was the most common call out of that data there? And number 4, what was our median? Okay, which is our middle call. Which is our middle call. So take a look at that and then spend some time, give me the answer in class. Thank you.